in other courses, in other math classes, and that's okay. I'm going to teach it like you really haven't seen it before so that you have the best possible chance of having a very successful chapter. Shh. Ratio is a comparison between two sets of things. So I'm going to give you 2 or 3 examples to remind you what ratios look like. For instance, I could do something like 2 red socks to 5 blue socks. Just a pure comparison between the socks you find in your drawer. I'm trying to think of the most elementary example I could have there, because maybe this is how you saw it back in grade whatever when you first did ratios. Yeah? But you can do comparisons between other things. In fact, at lunchtime I was discussing road signs and the relationship over here between speed, distance, and time. Look at that, 50 kilometers per hour. I could do a comparison between the speed of my car. I could go let's compare 50 kilometers to 1 hour.
I thought sock is spelled with an X.
You're not wrong. You're not wrong. Okay, socks is normally spelled S-O-C-K-S. For some reason, the Boston Red Sox spell it with an S-O-X.
Yeah,
It's not true. This is the proper way.
Brantford Red Sox.
Yeah, S-O-X, yeah, but it's S-O-C-K-S. Yeah. This happens somewhere else too. You know the Toronto Maple Leafs? It's leaves. With a V. But the Toronto Maple Leafs go F. I don't know. It must be sports. Too many hits in the head, and they just do whatever they want or something. Yeah. But I saw you looking at that confused. I'm like, why is he confused? What else can we compare? 5 cheese to 7 turkey slices. That was my lunch today. I went to Subway, and they put 5 slices of cheese for every 7 turkey slices on the new turkey sub they've got there. Okay? Okay so far? Nothing more complicated than that with ratios. Ratios, you can compare 2 things, and we put a colon between them to compare them. Some of you might be like, could we put these as fractions? And you could. Well, with ratios, we don't. We would do it with a colon. Okay? Any questions thus far? How many slides do I got to get through here today? Looks like 8 total slides. Okay? More time there? More time, okay. Okay, proportion. Shh. Folks, I cannot do the side conversations today. I'm sorry. I left all my patients out there before I came in today. It's not all your fault, but it is some your fault. Today, please, let's just get through this, shall we? Thank you. And don't wait until I just turn away and then start talking again. Here might be the most important word of the chapter. It's called proportion. And proportion is a statement of equality between 2 ratios. And this says 2/3 equals 4/6, which when you first look at it, you go, how can 2/3 be equal to 4/6? But can someone explain this? Why 2/3 is equal to 4/6?
I don't really know. I'm just taking a guess.
I love it. Let's do it. Let's guess.
If like you add the 2 to like the 2 and 2, it makes 4, and like 3 and 3 makes 6.
Yeah, he's right. He's right. That does work. You could go add 2 and add 3. So using his method, let's come up with a few more equivalent ones. Okay, but I got to be careful here because it says I don't want to break the rules here. I want to use, I'm going to go and find some other proportions. What else could 2/3 be equal to? 6/9. Because what he did is he added 2 to the top and 3 to the bottom again. So give me one more, and then I want to extend the rule. Some of you might see the extension of the rule. Somebody go big here. This was one bigger sort of thing. This is two bigger. What's really big?
12.
12? Hang on. This is the whole chapter in a nutshell. He's trying to think what number should go there. That's what he's trying to do. That's what we're going to do for the next 2 days. What number goes there? That's all we're going to do. And we're going to come up with different strategies. I'm going to give you a few different strategies. So he's trying to use a strategy right now to figure out what number goes there on the bottom. I'm going to put a box there going. He's trying to come up with an equivalent ratio. If it was 12 on the top, what do you like for the top, Chris? Or for the bottom, sorry. 18. How did you get 18?
Because 6 times 2 is 12, so 9 times 2.
Addition was right. Addition works. But you'll find multiplication to be more powerful. And all multiplication means is, you go, okay, he says I had to multiply this by 6 to get to that one. So you got to do it on the bottom. And you'll love these arrows. These arrows are everything. You could do that to solve proportions the whole time. You could just go, what am I multiplying by? Now, if the number gets difficult, I'll show you how to find the number if it's a difficult multiplier. But we've jumped way ahead. I've taught most of the lesson right here, on this slide here. That's what we're going to do. These are proportional. I'm going to underline that. Can you take a second just to underline that? And I want you to make an effort when you're doing this stuff to look back at the notes. These notes I'm building are not for my sake, and they're not so I get paid extra, and they're not to make me feel good. These notes are for you. They're my gift to you. So when you're having trouble, and you're like, what's proportional again? You can look back at the note. You can ask me, but you can look back at the note and find out. They're also called equivalent fractions. And if that upsets you, you're like, oh no, here we go with the fractions. This is not a chapter of fractions. It's not a chapter with all that fraction work you remember. They are fractions we're dealing with. But please don't worry that it's going to be common denominator and mixed fractions and improper fractions. No, we're not going to do much of that. We're going to do ratios, proportions. That is, two ratios that are equal. How do we find out the missing number? That's going to be the game today and tomorrow. Find the missing number. List 3 equivalent fractions. Okay, let's do 2 equivalent fractions that are easy, and then we'll need someone to do one that's a little more, with a little more spice to it. What's the most obvious? Shh. None of that's on the video.
I was on the wrong.
Oh.
I had that.
Yeah, good. Good, I like this.
None of what?
2 or 4 is the most obvious one to use. Now, Adam, did you use adding or did you use multiplication?
I didn't use any. I just
Yeah, you just knew. Yeah. I'm going to try and encourage you all to use multiplication when you can. Multiplication will be the more powerful method to get to big numbers. Let's jump ahead. Who's got a spicy one? Something with a little more oomph to it. 36 over it's good. He's thinking. Well, this is exactly what's going to happen. 72. But, okay, something happened over there, and we want to know what it was. We want to know what you did to come up with the 72. Because it's not simple to come up with the 72. What happened here to get from 1 to 36? What do you multiply by 1 by to get to 36? 36, yeah. So then you need your calculator, probably, to multiply that one by 36. Siriana, did you have another one with some spice to it?
Me?
Yeah.
Katie's talking.
No, I heard you. You said a spicy one, I think. 500 over 1,000. I don't know if you need your calculator for that or not. What she multiplied by, both top and bottom? What number did she multiply both the top and bottom to get from 1/2 to 500 over 1,000? She multiplied by 500 top and bottom. So here's the rule of the day. You can multiply by anything you want, as long as you do the same thing to the top and bottom. It'll be okay. Okay, 3/7, 2 equivalent fractions. What do you want to multiply by? Here, we'll test Mr. Todd's calculator brain. Pick a number and I'll try and multiply them both. He's giving me the answer, 6 over 14. What did he multiply by, top and bottom? 2. Something with a little more spice to it. Times, what do you want? 16. So if you multiply by 16, 3 times 16 is 48. And 7 times 16 is 112. But don't just add anything you want. You can't add anything you want. You can multiply by anything you want. So I'm going to multiply by 10. Maybe you want an easy one. If a question like this comes up in the homework, just multiply top and bottom by 10. You don't need a calculator for that. Usually, I wouldn't think. 12 over 20. Could multiply them both by 2. Could multiply them both by 100. But here's a little turning point in the lesson. You can also divide by anything you want. What number can you divide both these numbers by? They both will divide by 4, so I could do 3/5. So take a note of that. Write that on there. You can also divide by whatever you want. Do you have any questions? Can you get out of the way, please, Mr. Todd? Yeah, I will. I'm waiting. This? No, Mountain Warehouse. Look, I bought it because it's got zips here. It's got inside pockets.
What does your shirt say?
Garage sales. No, it's like, I'll show you in a minute. Any questions here? More time? Okay, now. I'm going to show 4 methods to decide if something is proportional. And I'm not trying to do a sales pitch for any method. So if it seems like I like one over another, I don't like one over another. It depends on what you're doing, which method you might like. Okay? So method 1 is find the number to multiply by. Now listen, the numbers in this chapter will eventually get too big or too difficult. So if you can figure out the multiplier by looking at 2 and 12 and you know what the multiplier is, then I'm proud of you, but you better listen to what I say next. To find that multiplier, to find out what you do to get from 2 to 12, what could you type in your calculator to find what it was multiplied by? 2 divided by 12. I'm going to go the other way because 2 divided by 12 is going to be a small number. I'm going to check and I'm going to go 12 divided by 2 to find out what this multiplier was. Division will give you the multiplier every time. So you've always got a way to get it. And what is 12 divided by 2? 6. And then I'm going to check the denominators. I'm going to go 18 divided by 3 and find that multiplier. And it's 6. Are the following proportional? Yes. Same multiplier. Some people love that method so much, that's all they ever do with proportions. They just divide to find the multiplier, and then they're off to the races. Once they know the multiplier, they're happy. Okay? That is not the only way. I could get a common denominator. Well, a little tiny bit of fractions here. That is, I could take 2/3 and multiply it top and bottom by 6 and find out it's the same fraction. That's another way to go. Others might reduce the fractions. That is, what number divides into both 12 and 18. I'm going to divide top and bottom by 6, and I find out it's 2/3. So that's another way to do it. It's just to get them with the same denominator. Some people go to decimals, though. I'm not going to get rid of decimals and all this. Decimals have their place, and if you type into your calculator 2 divided by 3, who's got a calculator there? What do you get when you go 2 divided by 3? Nope, 2 divided by 3. Six, 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 six. It just keeps going forever. What about 12 divided by 18? If you type that in, you get 0.66666. So you could check the decimals and see if they're the same. And they are the same decimal. So I'm not leaving decimals out of this discussion. I'm just saying it's one of the 4 possible methods that are available. The next 2 questions ask me to check if 2 fractions are proportional using at least 2 of these methods. I'm going to try and show all 4 methods eventually. But I'll let you choose what order I do them in. Do you need more time here?
Yeah.
Okay, you look back and forth at the methods. What method would you like to try first to see if these are proportional? There's 4 methods there. What's that? Find the multiplier. He wants to find the multiplier. So I'm going to go find the multiplier. So if I want to find the multiplier to get from 1 to 3, what do you do with the 3 and 1 to find the multiplier? So the top was multiplied by 3. Let's check if the bottom was. What's 21 divided by 8? It is not 3. What's 21 divided by 8?
It's 2.625.
These are not proportional. Can you just round, someone says? It's a good question. I'm going to say the answer for our purposes is no. In real life, would you be like, oh, it's close enough for what I'm doing? I don't know. It depends on what you're doing, whether it's close enough or not. We're going to act like it's not close enough. It's got to be the exact number, or we're not going to take it. Yeah? That was one of the methods. What other methods? There's 4 methods there. Which one would I try next? Find a common denominator. That's difficult here. Shh. I'm going to multiply this one, top and bottom, by 21. If you're wondering where did you get the 21 from, stay tuned for just a second so you can see where I got it from. If I multiply top and bottom by 21, I get 21 over 168. What should I multiply this one top and bottom by? You people who have your fractions remembered a little bit.
Oh, 8.
8. Oh, 8, he says, right? I took this one and multiplied it top and bottom by what was the other denominator. And this one I'm going to multiply by the first denominator, top and bottom. And I get 24 over 168. Are those 2 things equal?
Yeah.
21 over 168? 24 over 168? No, not proportional. Could there be a situation where you're doing something in life where this would be close enough and you say, hey, you know what, it's good enough? Yeah, I suppose there could be. But in math class, no, we don't take it. We go, no, not equal. It's up to somebody else to decide if it's close enough, okay? So what did I do? At that time I did find the multiplier and common denominator. On the next one, I'm going to do the other 2 methods. So get ready to name the other two methods. Do you need more time here?
Yeah. I'm good now.
Good? All right. Let's find out if 12 over 28 and 24 over 40 are proportional. Who's going to suggest one of the other two methods I didn't use yet?
Reduce both to lowest term.
Reduce to lowest terms. He's on fire. What divides into both 12 and into 28? Oh, we're doing, oh yeah, sorry. Lowest terms. We're going to get them both to lowest terms and then compare. Now, those of you who are not sure and this bothers you, you can still use your multiplication table. I'm going to get my multiplication table out here, and I'm going to look for a column that has both 12 and 28 in it. This thing's more powerful than you give it credit for. I'm not sure why people don't just walk around with this in math classes. You look for a column that has both 12 and 28. Ah, I found it. The 4 column. Jackson.
What if there was a multiplication question that was a decimal? Like that, equal and
We're going to get there. We're going to get there. Yeah. You ask a great question, and by the time those 2 days are complete, you'll see how to handle it. I've been using fairly friendly numbers here, but if we don't use friendly numbers, there's ways to handle it. So this one, I'm going to divide by 4, top and bottom, and I get 3/7. Next one, 24 over 40. So I go to my table and I try and find a column that has both 24 and 40. I found it in the 8 column. But I found both 24 and 40 in the 8 column. So I'm going to divide both these by 8. And your multiplication table gives you the answer. Some people switch over at that point. Then they go, okay, now I'll punch it in my calculator. But I can get right off the multiplication table here. 24 divided by 8 is 3. 40 divided by 8 is 5. Are these proportional? Are they the same? Again, you might decide at some point, oh yeah, close enough. But for us in math, not close enough, not proportional. What was the method I haven't done yet? Change the decimal. 12 divided by 28. 24 divided by 40. You get your calculator out and you hammer it in there and you go, what is 12 divided by 28?
It's approximately 0.4285.
Approximately, she says. So I'm going to put a dot over my equal sign. You don't have to do that, but I put that there to go, well, it's not exactly that. We rounded it off. There was more decimal places. And then what's 24 divided by 40?
It's 0.6.
Are these the same? No, and they're not really all that close, actually. Like you think about, let's say you had a test, and you got 0.4, you got 42% versus 60%. That's a really big difference in your life. These are not proportional. Okay, so there's 4 different methods available when it asks you, is it proportional? Any questions there? Finally, the big thing of the chapter. If you can master this, most of the questions in this chapter are really straightforward. Not like last chapter where it just kept coming, right? Factor this, factor that, x-intercept, y-intercept, graph this. It just went on and on. If you can do these, was there just 3 to do? I feel like there's a 4th one to do. Oh, there's a 4th one to do. Okay. I'm going to try to show you in 4 questions every way I can think of to do these. And by the end, hopefully you pick a way. You got it? He knows the first one. Tell us the first one, and then tell us your method, because I didn't even really teach a method yet. He's already got a method. So maybe you like his method best. Tell me what you do.
I got 12.
12 is correct. More importantly, though, tell us what you did.
I just know that. So
What do you know?
4 times 10 is 40, and to get 48, you need to add 8 more.
Yeah.
Which is 4 times 2 is 8.
Yes.
So I got 12, and then
He worked it out in his head that 4 times 12 is 48. How would someone do it if they couldn't do it in their head like you, or if the numbers get out of hand? You could use the math chart. You could say, okay, look at 4. I'm going to go to the 4 column, and I'm going to go down until I find 48, and there's a 12 sitting there. What if the number was too big for my table? How could a calculator help here? What could you do with the two numbers? So big moment coming, because you understand perfectly what's happening. But if the numbers get too big for you, you're going to need some help. What's the help? 48 divided by 4. So if you're not sure how he came up with that, if you go 48 divided by 4, you get his multiplier of 12. Okay? That was a lot of math in a couple of moments. So then, what did you do with the 12? I just put it in the box. Let's just make sure we know what we're doing here. Then you multiply that one by 12 as well. Okay? Because it was 1, it probably went very well for you. Yeah? All right. Then let's try this one. We'll do B. And I won't even charge you for it. No charge for B. No money. It's going to be a freebie.
Are you charging us for the other one? You did that.
Said that last time.
Oh. I know, but she didn't see it coming, so obviously she wasn't.
I didn't see anything.
Freebie.
I'm like really confused.
Freebie. It's a freebie. It's a freebie. Alex wants a shot. Listen to what he says. Don't listen to me. Listen to him.
21.
21 is correct. What did you do?
9 divided by 3.
He went 9 divided by 3, and you got what?
3.
3. So that's what was multiplied by to get over here.
Yeah.
But you didn't multiply by 3, did you? What did you do with the 3 to get back?
Divided.
I divided 63 by 3 to get there. Yes? So there's a little more brain to his method. He's like, let me just think this through here to get that other number. Good job. All right. Friends, please listen to this. I'm going to show you a powerhouse move. I'm going to reach forward and bring back a whole bunch of stuff in one step and do something that in the past my grade 10 students have loved. They love what happens here. Because instead of dividing and multiplying and thinking it all through, this particular move solves a lot of your problems. Here's what you do. This side's divided by x. So if I bring it over to the other side, it'll be times x. Do you remember that? The idea that the opposite of dividing is multiplying? So I'm going to do the opposite of dividing by x, but I'm also going to do the opposite of dividing by 17, all in one step. That is, now that 8 is going to get multiplied by that x, and that 24 is going to get multiplied by 17. It's called cross multiply. Students love this. And I don't mean like nerdy math students love this. I mean every math students love this because it takes what looks like a tough question and makes it easy peasy lemon squeezy. When this course ends and you leave grade 10, when this high school ends and you leave high school, you may still remember cross multiply and how it made one chapter in math very straightforward.
Is this our last unit?
No. That is some powerful mathematics right there. 8 times, shh. No, I'm offering options. I'm not doing a sales pitch. Okay, well, let's talk about that in a second, okay? Who's got a get your calculator out and you go, what's 24 times 17?
The answer is 408.
408 when I multiply those two things. Now, what's the opposite of multiplying by 8? Dividing by 8. So then I go, take the 408 and divide it by 8. You get out your calculator And you go, what's 408 divided by 8?
The answer is 51.
The answer is 51. That might be the most beautiful thing you've seen all semester. Yeah. Same, just steps that you like better. Yeah, you like how that looks better. That's good. All right, friends. Here's what I'd like to do. I put one challenging one, part D. I'd like you to choose between the methods. Look it over. And it's just as important if you get it wrong as if you get it right. The people who get it wrong are about to learn something about their method. People who get it right, I don't know how much they're going to learn. Try D yourself right now. Take a shot at this. Yeah, I'll go back. Those of you who are done that one, go to D and take a shot at it. Let's not wait till 5 minutes from now to find out you don't know what you're doing. Maybe get a calculator. Yeah. It might be time.
Oh, that's really close.
Who needed more time here? You okay now? And if we get it, let's share a bunch of different methods so people realize there's not one method to do this. Welcome back. Thanks for bringing the calculator back. Thanks for being in uniform. How are we doing in uniforms? Pretty good. Not a bad looking group. Jackson, is this the preemptive bathroom break? Did you finish this question? Bring your sheet to me. Hold on.
I actually did see the question.
I believe you. Let me look at it. 19A equals 1. It's beautiful. Show us. Show all the stuff you did. What? I don't know. Let's find out. I just told Jackson his was right. And he's sharing it with us. You check it out. And if you've got a different method, I want to hear it. And other people want to hear it too. So if you've got another method, please hold on. If you use the same as him, then great. Just hold on. Be patient. Just act like a nurse and be patient. Act like a nurse and be patient. I know, but I'm telling my joke. And you're not listening. You ready for my joke? Act like a nurse and be patient.
I have jokes too.
Yeah. Let it run around in your mind for a few minutes. Will this cross multiply method work in all the other ones? Yes. Every time. Yeah, you can. So some people love it. Yeah, it's okay to love it. It doesn't mean that you're. Thank you, Jackson. You may now go to the washroom. Did anyone else use his method? It's pretty good. Like, it wasn't just me being math teacher nerdy saying how good it was. I know math teachers like that sometimes. This time, oftentimes, the teachers like it and the students like it. There are other ways to do this. Did anyone do it a different way? Because we want to hear about it. Yeah. Did anyone do it differently? You're already all cross-multiply people. Did anyone try something different and get a wrong answer? You're happy? Okay. Don't forget the other methods are there. I'm not against them. It's just when it's all said and done, this is very popular. Let me show you one other way. Okay? You could find the multiplier. You could go 19 divided by 4 to find that multiplier. And you get your calculator and go, what's 19 divided by 4?
It's 4.75.
And then once you knew that it takes 4.75 to multiply the 4 to get 19, then you go, oh, then I could take 30 and divide it by 4.75 to find out my answer. What's 30 divided by 4.75?
It's approximately 6.3157.
Okay? So I'm not against that. But you see how cross multiply is a little more efficient. It's like bang, bang. You feel like you're cheating in math for once. You're like, wham, wham, I just do this and I'm done? And the answer is yes. Shamar, question. What? Yeah. Hang on, hold on.